Here we are going to discuss some examples on the parallel axis theorem. So do you remember the parallel axis theorem? What is the formula for the parallel axis theorem? I is ICM plus MD square, right? And if I take a rigid body like this, and this is the center of mass, I want to find out the moment of inertia about this axis, then I will take a axis parallel to this axis passing through the center of mass, find out the moment of inertia about that, and then add it with the MD square, where D is the perpendicular distance between these two axes that we know from the last class. Now let's move on to some examples on the parallel axis theorem, and then we will be moving on to some complicated examples of the combined perpendicular axis theorem and the parallel axis theorem. So in the first example, I have taken a ring, a uniform ring of mass m, radius r, and I want to find out the moment of inertia about the tangent perpendicular to the plane. You can look in this figure, the first one, right? Now I know the moment of inertia of the ring about its center, right? And you know that for a uniform ring, this center is the center of mass itself. And if I look, this axis and this axis both are parallel, right? So both axes are parallel. The perpendicular distance between these two axes is D equals to R. Mass of this ring is m, so I can say that I about this axis, let's call it as the z dash axis. So I about z dash axis is I center of mass plus md square. Look here, I center of mass doesn't mean any axis, about any axis the moment of inertia about the center of mass. That is not the case. The I center of mass meaning is that the moment of inertia about the center of mass about an axis which is parallel to the given axis. Like you can look in this case, right? So I z dash will be equals to ICM. Now do you remember what is the ICM? I center of mass of the ring about the perpendicular about an axis which is perpendicular to the plane, that is mr square plus md square, that is again mr square. So I z dash is 2 times of mr square, right? So this is how we can find out using this perpendicular parallel axis theorem. Now here I have taken a second example where there is a uniform disk, the radius of this disk is r, and I want to find out the moment of inertia about an axis which is perpendicular to the plane of a disk and at a distance of the r from this point placed on the perimeter of this disk. Okay, again I can apply I equals to I center of mass plus md square, right? You might think why I am not applying the perpendicular axis theorem, or why we are not using the perpendicular axis theorem. So if you look carefully, I cannot use here, right? Because by using the perpendicular axis theorem, we will be getting the moment of inertia about an axis which is inside the plane, but we need to calculate parallel to the axis which is perpendicular to the plane, right? Okay, so that's why we are not using that. Now I is ICM plus md square, and we know for this disk ICM is mr square divided by 2. We have done the derivation, so if you do not know, you can look in the previous lectures. I have attached the playlist, so you can go through that. So I is mr square divided by 2 plus md square, and is the perpendicular distance, and in this case it will be 2r. So that is m multiplied by 2r whole square. So that would be mr square divided by 2 plus 4mr square, that would be 9 mr square divided by 2. So this is the moment of inertia about this axis. Now taking one more example. Here there is a hollow sphere of mass m, radius r, and I need to find out the moment of an inertia about the given axis. You can look in the figure, you can find out the orientation. Okay. And now, by the way, if you do not know the moment of inertia of uniform sphere about the diameter, I can tell you the moment of inertia of the hollow sphere will be 2 by 3 mr square, right? And for the solid sphere, this is for the hollow sphere, and for the solid sphere it's 2 by 5 mr square. Okay, just keep in mind. Okay, so again I can apply the perpendicular axis theorem. I can say I equals to ICM plus MD square. So ICM would be 2 by 3 mr square plus M and D is RR 2R. So that is 2R square. This is the perpendicular distance, right? Let's start from the center to this point, that is 2R anyway. So that would be 2 by 3 mr square plus 4 mr square. So that would be 14 mr square divided by 3. So this is the moment of inertia. That's all for this lecture. Thank you.